Please introduce yourself.
My name is Ashlyn Gentry.
I'm Sierra Genne.
Masha Sokolova.
Isaac Cook.
Megan Galdony.
Brendan Kuncel.
Mary Smith. I am older than 5, and I personally believe that the only way to truly fix this country is if everyone only, walked on one leg forever.
That is brilliant, Mary.
Thank you, I really believe it.
Alright, so the theme of our room is Escape Physics 1.
Funny story.
It's what's actually happening. It's a reflection of the truth.
Wow. Incredible job. Sleuthing skills.
So Maame,
1,000.
You know, in AP classes, everyone always tries to leave and just get out as fast as they can. And the irony is that past a certain point, you can no longer escape, and you're stuck in this class forever.
That's ominous.
Okay, so I did the resonance tube, which is the first step to the escape room. And what we have are 3 tuning forks, each one with a different frequency, and only one of them makes a resonant sound.
Try all the okay. Let's try all of them. What does this mean?
Hit the tuning fork and it vibrates in the tube. And so that is the 500 hertz. And so you hit it on your knee and hold it over the resonance tube and it makes a sound.
So I'm doing stuff with Tesla coil and light bulbs. Essentially the way it works.
Oh, wow.
So this light bulb is a fluorescent light bulb, so when it's brought near the Tesla coil, the gas inside gets excited, which produces this light. These other 2 are a halogen light bulb and an LED. I took all the components out so there's no way they can possibly light up. And hidden inside this fluorescent light bulb, there is a piece of paper.
We have to beat the freshmen. Everybody's gotta love somebody.
At least once a day. Okay, once a day.
I'm working on the vector sums because we're forcing them to have physics fun in the form of using vectors to find key locations which will have hidden across the room. Okay, so starting from catapult number 1, the vector sum for this catapult will be hiding a key location right in here.
Why do you put something under a freaking table?
For catapult number 2, the vector sum will lead to that painting, which will have another key hidden behind it. And then the final vector sum will be starting from this catapult and going right over here. It will be the final key hidden.
So I did the catapult, which involved projectile motion and elastic potential energy. So obviously the projectile motion is when you launch the projectile. And then the elastic potential energy is with the rubber band.
You're a physics genius, Katie. No stress.
So at each catapult, they're color coordinated to keys that are hidden around the room. And then you have to launch the key and each one is calibrated so that when you launch the key, it hits one of 3 targets. And that'll tell you what the key unlocks.
We did a step that involves elastic and inelastic collision. Tennis ball goes right here. Marble rolls down. Only one of my objects lands in the cup.
Is this relevant?
No.
Okay.
You can keep that for good luck.
Objects, they're all labeled period 5, period 1, period 2, period 3.
This and or these are not related at all.
Does it have a number on it?
5 leads you to an accordion folder. So one of these papers has a code. It's got arrows in the top corner. This then leads you over to what we call the rubber band box. The code is what that paper gives you, and it unlocks it.
Okay, so the next part of this escape room is a 3-part puzzle. You have a black light in this pink box. So basically you have to take the bulb out of the flashlight. So you put the batteries in. The batteries are in series because the voltages have to add up to make 4.5, and that's what it takes to turn on the bulb. So the red part goes with the springy part of the bulb, the red wire, and then the black part goes with, on the little corner right here. It turns on, and when you put it here, it gives a little hint.
it.
Oh, for that? Interesting.
Sounds awful. I did the torque balance puzzle for this experiment. Basically what players have to do is they have to find the balance point, which is 13. Torque is the quantity that measures the ability of a force to rotate an object about a fixed axis of rotation. In this case, the rotation point is the fulcrum of the ruler, and we also have this note here, which says that the balance point is the first key to the lock.
I think it's just 13. So 13, 31, 33. I like chemistry and biology. Got it.
No, I think Masha and Megan got together and they kind of like just discussed it. And then we all got like these ominous texts and they're like, we have an idea. We have a proposition for you.
Right? I was like sitting at home trying to watch TV.
Yeah, I had like just gotten out of Polo Practice.
I was like considering a different idea when I got the text. And I was like, you know, even if it goes down in flames, I'd rather go down in flames with a group of people I like than like do okay by myself.
Like, it was quite hot, but it was fun. Yeah, it was. It was a little tricky. Tricky? Like, what parts were tricky?
Physics.
Physics.
I kind of hope that Miss Coughlin doesn't see these. That she has like proof that I'm a dingus.